Hello, everyone. My name is Liudmila Strelnikova, or just Mila. I'm an undergraduate student at Memorial University of Newfoundland and Labrador. And today I would like to present to you the results of a project that I was working on last summer. It was supervised by Dr. Erica Mishrod and sponsored by Summer Undergraduate Research Awards. In one sentence, the purpose of my project was to perform non-invasive question document analysis with Raman spectroscopy. I now quickly want to go through the necessary vocabulary so that this sentence makes sense to everybody. My supervisor in this work was Dr. Erica Mishrod, as I mentioned before, and Dr. Mishrod's research interests lie in the field of surface science. A common technique that is being used in her group is Raman spectroscopy. Raman spectroscopy is a non-invasive analytical tool that involves inelastic scattering of light and is used for identifying the chemical structure of compounds of interest. Question document examination is a term used by forensic scientists, and which means the analysis of documents that might contain evidence of a crime. Most commonly, we're talking forgeries, as in forged checks, contracts, currency, etc. In these cases, the job of the examiner is to find if any alterations, substitutions, or erasures have been performed upon the document, and if possible, to identify the source of these alterations. So how is question document examination performed? Well, there are two parts to it. The first question you got to ask yourself is, are there two different ink sources? Because if they're not, maybe it's not a forgery. So the first part of the analysis is pretty straightforward. Different inks respond differently to various light sources and light wavelengths. So to identify if some text was altered with a different ink, the sample is exposed to radiation filtered at various wavelengths using a piece of equipment called video spectral comparator. And you can see the principle and the results of its work in the picture. To determine individual dye components, we got to ask a question: what are the sources? And the most common techniques used for this analysis is chromatography and mass spectrometry. And as we all know, hopefully, those techniques are invasive, and you actually have to cut out a piece of your precious sample, precious analysis for examination. And that is where Raman spectroscopy and the motivation for my project comes in. If we could reliably perform non-invasive question document examination with Raman spectroscopy, it would be of enormous value to Canadian law enforcement. Several research groups around the world have attempted to do similar work. However, they were investigating ball pens and gel pens, and only two research groups, to the best of our knowledge, were studying filter tip pens and markers. And neither of the two were sampling North American brands of pens. So we decided to do this type of investigation with filter tip and marker pens. Before COVID started, we all had plans, and we had an investigation plan, which consisted of obtaining the samples, performing the chromatography, collecting the spectra, identifying the peaks, and then creating the database website to store the results, which could later maybe use, if successful, in forensic science labs in Canada. So the first step went well. 14 samples were obtained from local stores. Preliminary solubility tests with ethanol, water, and acetone were performed in order to choose a suitable solvent system for chromatography. From now on, everything that's been done here was done from work. If you're from home, if you're wondering, these are ice cube trays, very effective for this type of analysis, as we found out. Now, we did not have access to the lab, but I had access to the grocery store. So the way I obtained the organic solvents used in this analysis I built a distillation apparatus which looked as follows. Acetone was obtained via distillation of a nail polish remover. Some of them still use acetone. The distillation went well, and the purity of acetone was tested with styrofoam. The piece of styrofoam that I used did not dissolve in nail polish, but was readily dissolving in its distillate. So that's how we knew that the necessary purity of acetone was obtained. Ethanol was obtained via distillation of liquid hand sanitizer, which was probably the symbol of last year. At the end of the day, the most efficient solvent system was found to be 80-20 ethanol water, or just ethanol of whatever purity it was obtained. So we still did not have access to the lab, and we decided to jump right into creating a database. And oh yeah, paper chromatography, sorry about that. After we got the preliminary solubility tests and all the solvents, paper chromatography was performed with a lot of trial and error, as you can see on the picture on the right-hand side. Choosing the right paper was definitely a problem, but at the end of the day, we got the chromatography results, and as you can see, the spot separation is good, and these plates can later be used in our later analysis. Back to creating a database. Prior to this, I had no experience in making databases or making websites at all. But COVID did its thing, and this link here is my first test website. It's not the database website that we made, but it is a test website that is readily available to you if you want to go look at that. And it is about how to make a website so that I later don't forget how to do that when I'm making a database. The database kind of looks like this. Unfortunately, I cannot really show it to the public yet. It looks better than this, but the common structure is presented here. You can add the paper or the pen that you're investigating. You can add its spectra, branded color, as well as you can search for pens. And this is the kind of databases forensic scientists will hopefully use. September came, and we were so excited because we had access to the lab, and I was so excited because I had access to the lab. I could finally take the precious spectra of my samples. However, due to the lack of use during the summer, the spectroscope broke down, and we're still waiting for it to be fixed. If anyone listening to this talk has access to the work environment spectroscope, please let me know if I can send you the samples for analysis. That'd be great. So these spectras here that you're looking at are the only spectras that I was able to obtain. And what you see on the picture is a typical Raman spectra. Raman graph. On the x-axis, we have a Raman shift in wave numbers, and on the y-axis, it is the intensity. And 7, 11, and 12, and 14 are just the numbers of the samples, because all of my samples were numbered. And this here is just the paper background. So as you can see, all the spectra are very different, which gives us hope that every single ink formulation is unique, and we can reliably and repeatedly identify a pen just by its Raman spectra, which is pretty fascinating. I like these results right here. So the fact that some of the peaks are matching might be attributed to the fact that most pens use similar dyes, specifically pigment blue 15. That's the structure of pigment blue 15, pigment violet 23, and pigment violet pigment blue 60 on the right-hand side. All the papers where these pictures come from, there are references to those papers at the end of the presentation. But using these papers, using this work done by other people, we were able to identify that, for example, this peak right here is attributed to pigment blue 15, this peak right here to pigment violet 23, and this mountain range here from 1,000 to 1,500 is probably attributed to pigment blue 60, as you can see. Sorry about that. My presentation does not want to go smoothly. The fact that some of the peaks are different might be attributed to the fact that ink is a very complex medium. It consists of solvents, pigments, lubricants, surfactants, etc. And during COVID, I have simulated the Raman spectra of some common solvents and additives that could be used in filter tip pens, such as xylenes, propanol, formamide. However, peak matching to the spectrum that we already have still needs to be done, and it is a work in progress. I wish I had more data to show to you today. Once again, let me know if you have a work in Raman spectroscope. However, so far, I love the results that I have. It's pretty exciting. In conclusion, Raman spectroscopy is a very promising analytical technique in forensic science. And judging by my preliminary results and work of other great researchers, it can help us identify the source of pen marks when analyzing crime evidence. Even though the work was slowed down by the coronavirus pandemic, some science was performed from home, either by means of homemade apparatus or technology. And even though the work was slowed down, it was definitely fun, and I want to encourage everyone to try to do their science from home during lockdown. I'm looking forward to finish my project now that I'm back in Canada, and I hope to present my results to all of you next year, and maybe some more results, maybe some new projects. Yeah, you can enjoy the wonderful pictures here. This was one of my first results from chromatography from home. Looks terrible. This is our broken spectroscope. It is supposed to be a dot, but it is a line, unfortunately. And this is just a picture of a homemade heat device. Works pretty well and looks pretty cool. As promised, the references. And thank you all for your attention. Enjoy the conference. Thank you.